Hey guys, this is the lecture for 2.2a on pages 85 through 90 in your textbook. The big idea we're going to be working with here are understanding the difference between a parameter and a statistic and knowing how to limit bias and variability in a sample. So please join me on that page. The first thing we're going to do is define parameter and statistic. So here I have a parameter, and they call that P. That's how that's the variable they use, is a number that describes the population. So an easy way to remember this, the P, the parameter, stands for the P word here, which is population. And a statistic, or P hat, they call that P hat, is a number that describes a sample. So again, here you can use an S for an S. A statistic describes a sample. So that'll help you when you're looking at test questions, quickly differentiate between which one is which. All right? And then if we can go over these examples on page 86, the first one is 2.26, and it is ketchup bottles. So if you look at that, if you can turn to page 86, okay. On Tuesday, the bottles of tomato ketchup filled in the plants were supposed to contain an average of 14 ounces of ketchup. Quality control inspectors sampled 50 bottles at random from the day's production. These bottles contained an average of 13.8 ounces of ketchup. So not quite as many as they were supposed to be looking at, right? As they were supposed to hold. So if we go back, we're trying to figure out. So our population here is going to be all bottles of ketchup in the factory. That's the entire population of ketchup bottles, okay? So the population, all bottles in a factory. The sample are those 50 bottles that they chose at random to actually test. Okay, that's the sample. So if we look, and we can use our letter shortcut, the parameter matches up with the population, okay? So what were the ounces of ketchup supposed to be for all bottles? Well, they were supposed to be 14 ounces, right? So that should be the parameter. The statistic is that only 13.8 ounces, because this is out of the 50 bottles that they sampled, the proportion was 13.8 ounces per bottle, okay, and statistics always going to be a proportion out of that sample. So the statistic number is 13.8 ounces, all right, and the statistic, S, is going to match up with the S in the sample. So ounces is what we're looking at, all right, that is going to be the now I'm forgetting, I'm sorry, I'll come back to that. But the ounces is what we're looking for, the identifier, what we're looking for the population and the sample. And it's supposed to be 14 ounces for all bottles. When we looked at our sample, the proportion only came up as an average of 13.8 ounces per bottle. Okay, and one more example here, the one right below it, 227, flight safety. I'll read it for you. On a New York to Denver flight, 8% of the 125 passengers were selected for random security screening prior to boarding. According to the Transportation Security Administration, 10% of airline passengers are chosen at random for screening. So, flight safety on page 86, the population are all airline passengers. Okay, that's what we're looking at. The sample is that 125 passengers that we were looking at from that one flight from New York to Denver. The parameter is 10% because 10% of all passengers are supposed to be tested for screening. The statistic is 8% because only 8% of those 125 passengers, or let's do the math, what is 8% of 125? 10, only 10 out of the proportion would be, like we said, you can always write a statistic as a proportion. So the proportion would be 10 out of 125. Okay, that's going to be p hat. Only 10 or 8% were actually chosen to be looked at. So the statistic matches with the sample and the population matches with the parameter. Easy peasy. Some questions are going to be a little bit harder. You'll see on some of the quizzes. But just ask me if you have any questions about that. All right, the second part of 2.2a that we're going to be looking at is variability and bias, and how do we fix those two things. Okay, so I know we've looked at bias a lot. Just one more quick definition. Repeated deviation in the same direction, the same problem in the same direction each time, like that scale. If it's off, I get on it every day, it's 3 pounds too heavy, that's bias. It's always wrong in the same direction. Variability, the extent that data differs from each other, the spread of the data. Okay, so variability is going to be like, if I keep choosing different samples, I'm going to keep getting different p-hats. I'm going to keep getting different statistics. A large variability means you really don't have any idea what's happening in that population of people. So how do we fix bias and how do we fix variability? To fix bias, and I think we talked about this before, you can use a random sample or a simple random sample. Okay. Bias, if you remember, came largely from those types of surveys that people called in, right? Or if they wanted to, if they were upset enough about something that they wanted to call in and do this response, the voluntary response, that was going to cause bias, because normally people were going to feel strongly in the same direction about something. To fix that, you take a random sample, so it's not the voluntary response, but you're just randomly picking people to respond. That's going to fix that bias. To fix variability, you need to take a larger sample. So this becomes really important. You really need to read about this on page, let's see, starting on 86 to 88 here. Okay, and what it's going to look like is it talks about, it goes back to that, what is this one talking about? Oh, just choosing paper. So there's also a regular pattern. Okay. I'm not sure what they were doing for this poll, but they were taking samples. And this graph right here, that it turns out to be, if they're taking samples of 100 people each, the statistic can be anywhere from 0.56, 0.46, 0.61. See how the spread of this histogram is really wide. I mean, it is a normal curve, so it has a pattern, but the variability is so large that the spread is really wide. It goes all the way from here. One sample only had this percent, this proportion. One sample had this percent over here. If we go back and look at the parameter, or what it's supposed to be, I think it tells you what the parameter is supposed to be in this problem. The truth about the population, that's the parameter, is that P is 0.6. So that's going to be right here in the middle. This is the actual parameter, what it should be. But if you look, all of these samples, the variability is huge. It goes all the way from 0.45 up to 0.75, a huge variability. Now remember, this is from random sample of size 100 people each. If we turn the page, here at the top of page 88, okay, it shows you a sample when they take, instead of just 100 people, if they're looking at 1,523 people, if that is your sample size, your simple random sample size of that many people, look, your variability is going to be between 0.55 and 0.65. So your variability is a lot smaller than it was when we were looking at sample size only 100. So that's a huge idea that we're going to talk about. So you need to remember that. So it doesn't look as pretty. It's not the normal curve, but these numbers are all a lot closer. These statistics are all a lot closer to the actual parameter from the data, and that's what we're looking for. So please remember that to fix variability, you need to take larger samples. To fix bias, you need to take random samples. And then what I was talking about, that normal curve, if you look here, variability follows a pattern. Lots of random samples of the same size follow a predictive pattern, and that was that graph. We were just looking at the normal curve. If there's smaller samples of like 100 and you keep taking those samples 100, it's going to follow that pattern. You'll be able to figure out the pattern of the variability, but guys, it's just a lot easier to take a larger sample. Okay, last picture I wanted to show you is it's just going back over on page 89. Bias and variability here, it has those definitions if you need to look back at them. And then down here in the book, it has this. I really like this figure. I feel like it really explains what's going on. It uses an arrow target to look at the two types of errors that we're looking at, the variability and the bias. So here, this is large bias because all of the arrows are away from the center in the same direction, but small variability because all of that data is linked together, is really tightly packed together. So there's not a lot of difference in the data. However, the data is off all in the same direction. B, small bias, large variability. Well, the bias is small because even though they're not in the center, they're not away from the center in the same direction. Variability is large because each of those points is far away from another point. Like, you don't know what's going to happen when you take a sample. Here you have no idea what's happening. Large bias, large variability. Okay, the bias is large because it's all in the same direction again. Variability is large because the points are not packed closely together. And here, this is where it wants to show you really hit your target when you're doing a survey if you have small bias and small variability. So that means everything's in the center, there's no bias, and everything's packed closely together, so there's no variability. So let me know if you have any questions on this stuff. Please go back and read these 5 pages to yourself and make sure that you're following along with the notes. The notes should be on the link below. And I look forward to seeing you guys next time.